Hello students, welcome to Vyas Certification Kota. In this series of NCERT discussion, we are dealing with mathematics class 12th and the big chapter of integrals is being covered right now. We'll move on to exercise 7.11, that's next. And this particular exercise is based on one very important concept. What's that? The properties of definite integrals. We should be aware of all the properties of definite integrals and how to use them in solving questions. It's along with the questions we'll be seeing the properties. Let's move on to the first question without wasting any further time. Question number 1 says, by using properties of definite integrals, evaluate the integrals in this following exercises. The first question says integral from 0 to pi by 2 of cos square x dx is equal to what? Now let's take a look at this. One very important property is this. Let me write the property in front of you. Integral from a to b fx dx is equal to, this is equal to integral from a to b, the limits remain same, the function is replaced by f of a plus b minus x dx. This, or as a special case, if this a becomes a 0, this becomes a 0, 0 to b, f of b minus x is what you encounter over here, right? Very special. It is referred to as the king property, right? Very important, yes. Okay, in the NCERT, this is property number 4, I suppose, property 0, 1, 2. This is P3, right? So, integral from 0 to pi by 2 cos square x can be handled with this, yes? Because I see 0 plus pi by 2 is pi by 2 minus x, okay, cos pi by 2 minus x will be sin x. And let's see the benefit of applying this property now. In general, if I want to solve this kind of equation, I'll have to integrate first. But see the steps over here. Integral from 0 to pi by 2 cos square x dx is what I have. So applying this property, I can say this is I and this I is also equal to the same limit 0 to pi by 2 cos square x is replaced with this pi by 2 minus x. Yes, dx, using this, right? Okay, while appearing for the board examination, what you can do is using this, you can write that complete expression over here, right? And this becomes, now this particular expression becomes integral 0 to pi by 2 cos square pi by 2, cos pi by 2 minus x is sin x, so this becomes sin square x dx. Yes, okay, so I in this step is equal to this, I in this step is equal to this, and if you see, I can add 1 and 2. I can maybe add 1 and 2, and that tells me 2i overall, since this is also I, this I plus this I equals integral from 0 to pi by 2 some function dx, integral from 0 to pi by 2 some other function dx, which will be integral from 0 to pi by 2 the sum of the two functions, which is cos square x plus sin square x dx. Oh, but what is cos square x plus sin square x? That's simply 1, yes. So this is equal to integral from 0 to pi by 2 of 1 dx. And what is that? Integral of 1 is x. From 0 to pi by 2, this is what you get. And that becomes pi by 2 minus 0 by substituting the limits, which is pi by 2. This is the value of 2i, therefore I will be equal to what? Pi by 4. And yes, that is the way to get this answer, as you can see clearly on the screen. The important thing, using this property over here, do you see that there's no integration involved as such? Very simple integration is involved. Here directly we would have had to reduce this to a lower power by applying concepts of trigonometry, and after that integrate some expression, some trigonometric expression, and then substitute the limit to get that answer. But here simply applying a property, I see that cos square x converts to sin square x, I add them, and the integration is very simple, as you can see over here. That's the solution of this first question using properties, right?